Hello. Welcome, everyone. To start, I'd like to start with a quick question. By a show of hands, how many of you used your mobile phone to make some sort of payment within the last week? As I guessed, practically everyone. So, payments are an integral part of our daily lives. Whether it is paying a few dollars for a cup of coffee, or like in my case, sending a whole bunch of dollars for my daughter's college education to her university. Now, behind the scenes, there is a complex and comprehensive technology infrastructure that makes this money movement and these payments possible. And in this session today, you will learn how FIS collaborated with AWS to build a high performance and massively scalable payment solution on AWS. My name is Samir Sharma. I'm a lead principal technologist and architect at AWS. And today I'm joined by Aid Sturley, Vice President of Money Movement at FIS, and Nilango Sundarajan, who's a Senior Delivery Consultant at AWS. And together, we will share some key learnings and insights from our journey so that you can take these away and apply as you build your own mission-critical applications on AWS. So let's get started. Here's a quick overview of our session today. We'll first start by telling you about FIS and the critical role FIS's technology plays in global financial services. And Aid will share with you why FIS decided to rethink payment solutions from the ground up. Then we'll show you a quick demo of instant payment processing. The goal here is to show to you the complexity of the processing that happens to make every single payment possible. Then we'll touch upon briefly the requirements, technical requirements and challenges in building such a solution. But most of the time in today's session, we'll spend diving into the solution. We'll share with you the architectural design decisions that we made, the trade-offs that we balanced, and the technologies and services that we use to build this solution. We will also take a deep dive so that you can understand how we approach building massive scalability, high performance, high resiliency, and end-to-end observability. All of these are key pillars of building business-critical applications on AWS. And hopefully, you will learn some unique insights as to how we did it. Then we will pivot and talk about a few things that are enabled by the architecture that we have designed in the roadmap. And finally, we'll conclude by sharing some of the key learnings and lessons that you can take away. With that, I'd like to invite Aid on the stage.
Thank you, Samir, and good afternoon. I'm Aid Sturley. I'm the Global Product Manager for Enterprise Payments in FIS, and I'm co-inventor of the solution that we're going to show you today. I know everybody is really keen to see the technical deep dive solution beats, but if you just bear with us for a little while, I want to try and give you the why we did this based on our history of providing payments in the payments ecosystem around the world. Every day, payments move silently, securely across the globe. In fact, trillions of dollars move silently and securely across the globe. FIS is behind a lot of that movement. We're a silent, invisible player in the background of processing those payments. When Samir transferred money to his daughter today, when you guys bought coffee, when you checked your retirement balance, it was very likely FIS was running behind the scenes in that area. And we think of money in three stages: money at rest, money in motion, money at work. Money at rest being the secure and an appropriate core banking storage of the accounts that you use every day. FIS processes 58% of large and retail organizations in the United States with our core banking and payment and digital solutions. Money in motion, very much around moving payments, treasury, risk management. Today we process 16 billion transactions annually through our card and non-card networks. And then money at work. This is where we are using trading and lending and wealth and retirement. And we're managing 8 trillion assets for our customers today. So we're not a startup. We're a big company. We process at scale. Over 95% of the world's largest organizations use us globally. We move over $16 trillion of payments annually. And we work with over 50% of the world's most innovative companies. And the scale piece of this is really important for everybody. If you imagine the years that we've been working, around 60 years overall, you can start to see how we've had to evolve that payments and those processes over time. And that makes us, and seen us go through many revolutions of the payment ecosystem. And this is important because we're doing this again. And partly this is because payment and experience and expectations are changing. Everybody in this room is making payments over their mobile phone. Everybody in this room and outside wants things to be faster. And I got a great story to tell you that just happened to me this weekend to try and give you an example of why our expectations have changed. For some reason, I accidentally overpaid a credit card. And I want to try and close the account that was associated in the banking because I'm moving banks. I phoned up. I was told to call back between 9 and 5 in a weekday. I called back, and the basic option was, well, what we'll do is we'll refund you the amount of money on your credit card, and we'll send you a check in the mail. Now, that means I've got multiple processes I've got to do. I've got to receive that check. I've got to go down to a branch. I've got to put that into a different bank. So it's not automated. The second option was transfer the money to an account, and then up to you to move your money out of that account. And again, I'm into that non-automation. So we're seeing a disappointment in the way that we want to actually move money. I want to be able to take money out of when I want to. I want to be able to transfer that as quickly as possible. And I want to do that in an embedded, constructive way where I'm not using multiple apps in multiple different ways and taking my time to make that process. So our expectations are causing a revolution in payments that we want everything to be done really quickly. And this causes problems. It causes problems for the financial institutions themselves. If we think about rails, payment rails, the traditional batch types of payment rails that we're all used to are now changing. They're moving more into instant rails, but they're being added to. We're moving on from ACH and wire and other forms of payments, and now we're seeing all the other types of payments come to fruition, including instant payments. We're seeing things like FedNow and TCH RTP gain traction. We're also seeing the additional payments coming from things like Venmo and Zelle and other types of payment-initiated types. We also expect things to be always on. So as things operate in a bank which has traditionally been very much a batch-oriented service or a 9-to-5 service, now we're always on. I want to make payments any time of the day, no matter when they are. And that changes fundamental batch operations or fundamental operations within an institution. And if we think about how these were all wired previously, lots of payments were wired into digital environments, they were wired into core environments, and it's like spaghetti. And we're only adding to the problem when we bring new rails forward, like digital currency. And the way the banks used to win, they used to do it by rates. They attract you by rates. But the trouble with that is now experience is taking over rates. The experience that we have is more important. The faster that we can make things happen is more important for us. So we're seeing experience win over rates. And we're seeing the large, big banks win that game because of the experience they're providing. And of course, we've got to comply with all the regulations and the compliance and the risk and everything else that goes forward with that payment ecosystem. So we're seeing a change in our behavior, and now we're seeing the problems it's causing in their financial institutions. In FIS, we decided to rethink the way that payments are made from the ground up. This was despite us having lots of different payment systems. We had lots of legacy payment systems. We had ACH silo systems, we had wire systems, we had real-time systems. We deal with bill pay, we deal with Zelle, we're a major Zelle provider. And we do that in very much isolated cases because our clients needed those rails at the time that they needed them. But rails are table stakes now. The most important piece, that the big brain of the power that we now need, is in orchestration and execution. We need more flexible orchestration and execution to be able to determine how payments should be made. What is the fastest, safest, cheapest way and the strategic way that we want our financial institutions to be able to make payments? Those are the things that matter. The value drivers are now liquidity, risk management. They're not about moving money. And that's because we're able to move money in so many different ways in the choice that we make. But we also need to think about how we need to move money in a more intelligent way. Why, for example, do I need to make a decision whether I want to put something over ACH, wire, instant, digital currency? Why can't that be automated? And why can't I have that offer to be automated or allow me to make that call? If I want to make, and I want to classify a payment as being, I want to make it now, that's real time. If I want to make it tomorrow, that's ACH. If I want to make a high value payment, that's different. If I want to move money over a particular coin, that's digital currency movement. It shouldn't matter what they are. And the intelligent piece of this is the more appropriate area. So, rails aren't plumbing. Rails are just always going to expand. Everything's about orchestration, everything's about execution. And we have to think about, therefore, how do you bring all the rails together? How do you orchestrate those from single exit points, entry points? And how do you make sure that your decisioning is done in real time? You have smart routing. You have intelligence behind the decisions that you're making. You're providing the capability for those things to be programmable for the institutions that we work for. And you're providing the mechanism to have inline risk management and fraud. So we thought about the payments from the ground up, despite, as I said, us having lots of payment systems around the globe. And we got to an aha moment, probably the beginning of 2024, when, working together with our AWS friends, we came up with a solution that we called the Money Movement Hub. And really, this was about putting all of those practices in place. The challenges that we were facing because of the expectations that were changed from all of us. And the challenges that we saw our financial institutions having, that we had to go and provide fixes for, and a different way of making payment processing. So we built a solution which was in the cloud, built from scratch, designed for multi-tenancy, designed to provide multi-rail access to our customers, designed to interact to multi-digital environments, and designed to integrate to multi-core environments, both in FIS and outside of FIS. And that was a specific challenge for us, given the fact that we traditionally built these single isolated rails, which were extremely successful. But also building this for 1,000 institutions and moving millions and millions of payments every single day across those rails. The biggest part of the process in this is very much how do you bring together so that you protect the future of our institutions, so they don't have to introduce new rails. And we'll talk a little bit about that later on. I'm going to show a little demo. I want to show this from a perspective of execution, not perspective of what you see from a payment initiation. There are lots of people who make payment initiation. So bear with me a second while we bring this up. And you should see this. Well, you should see this. I'll get Alango can go fix it for me. While we're talking about the demo, it's really important to understand what we put together. So we created a universal API for all payment types. That universal API is exposable to our financial institutions or their customers. That was critical for us to basically take any single payment type and drive it through those areas. So we use a standard paying one message, if that makes sense for anybody working in instant payments. But we made that work with ACH and the other payments types. We also, however, creating SDKs and designing those from a payment initiation, so to launch those SDKs into our digital providers, who are much more turning now into what we call portal technologies. So important for us was putting something together that showed behind the scenes how things would operate from an execution perspective. And what I'm going to show you now is more about that execution and that orchestration than actually the initiation of the payment. So let's take a standard UI looking forward transaction transfer. You see your balances, you want to make a transfer, you decide to basically go and click on the transfer, I want to try and move money. You'll see a standard type of transfer money movement screen. We're trying to capture the information from the customer, we're trying to capture the information from the perspective of how much we're paying, we're trying to capture the information of who we're paying, etc. And in this case, we're paying Jane. And we're just transferring money for the purposes of paying for tickets to reInvent. I'm going to show you what's happening behind the scenes in this area. So this is the API. You'll see how it's basically constructed, standard pane 001 message. But you'll also see that if I go in here and I want to make some changes, and I say I want to pay $100 instead of $150, you'll see the dynamic API being updated. And I'm going to put Disney World tickets in this one, but I'm actually going to pay for reInvent. Okay. And you'll see how that's dynamically changed in that API. And again, the purpose was to expose that out to everybody so that this becomes a standard way of interacting with us. Whether you're doing a ACH file in terms of an ACH set of transactions, in mass transactions, or whether you're doing a single instant transaction or a wire, etc. This even works for the digital currencies, slightly different screen. You'll see a lot of FX rates in there that we've got, but it kind of gives you the idea of what's going on. And then I want to scroll down, you'll see there's a submit transfer. So as I submit transfer, we're doing very, very quick validation check. We're making sure that that transfer can be done. You'll see, as I scroll over the areas, you'll see the areas in here being updated. You'll see the name of Jane and the changes that I've made in that payment transfer. So I'm going to make a transfer. Things happen incredibly quickly in payments. We have to transact in less than 5 seconds for instant payments. That means a conversational with the rail itself. I'm basically asking the question on a send, I want to send you some money, do you accept it? But before I even get there, there's a load of things that are happening in the background. I'm going to go back in a second and show some of these things. And then we're on the other side, we got the receive. So now it's about what am I doing as the receive institution. So let's go back and have a quick look at those things. So all the validations that we did, right, as part of that service, we checked the core banking systems. So we actually went out from APIs calling to the core banking systems. Is this account valid? Does it have a money to make sure that transaction can happen? Is the status of that account in a good status so that allows that to happen? We also looked at, okay, so what about fraud? Well, we want to make sure that we're checking the fraud mechanisms so that we're checking for transaction screening, we're checking for AML, and we're checking for transaction monitoring. And we're doing that in line in the transaction. And remember, that time frame is 5 seconds, back and forth to the scheme. We're also posting to the core. So we're basically saying, okay, if I want to basically move the money that I did for $100, I now need to be posting that into the core as a debit for the send transaction. And again, everything has to happen with a back and forth to the scheme within that 5 seconds and at scale. On the receive side, you'll see that we did a very similar thing. So on the receive, especially if it's not on us is different, but if we're doing a receive transaction that's coming from outside the scheme, then we're also going back into the account. We're checking that account can receive that credit. We're checking if there's any particular issues with that account receiving it. And we're checking the fraud of the incoming item on both the sender and the beneficiary of those transactions. So there's a lot going on a very, very simple use case of an instant payment. And all of that has to comply with all the regulations that happen across the multi-schemes and obviously within the time frames that are set for the experience that needs to happen. So I'm going to hand this now back to Samir, who's going to go finally, you say, into the technical details of the solution. And we'll speak a little bit later about the outcomes and what we received and what we achieved.
Thank you, Ed. So I have had the privilege to work with FIS and rest of the FIS team, with Ed and rest of the FIS team, since the day they decided to rethink payments from the ground up. So what we did, the very first thing we did, obviously, was we started collecting all the requirements. And as we always do, we collected all the functional and non-functional requirements. Now, there is a humongous list of requirements for a solution like this, but let me just highlight 3 key technical requirements that we had to meet, which define the key characteristics of the solution that we built. So first and foremost, on the performance. Now, each payment rail has its own performance requirements, but for us, for Money Movement Hub, we set the requirement to not only execute, but settle the payments in under 5 seconds. Now, for payments, this is instant payments and real-time payments. For scalability, Money Movement Hub is a multi-tenant solution. What that means is many financial institutions are simultaneously sending payments through Money Movement Hub, which means at any given point in time, the payment volume can be exceptionally high, and it can also go down exceptionally low. So the solution has to scale dynamically and rapidly up and down. So we designed the system to process over 1,000 payments per second, right? And finally, on availability, obviously we said this is not a 9 to 5 solution. This is a 24/7, 365 days of solution. So the requirement on availability was 99.995% availability. In real terms, what this really means is we can afford less than 30 minutes of downtime in an entire year of operation. Apart from some of these key requirements, we also had to overcome some key challenges. Payment solutions don't live in isolation. They need to interact with existing banking solutions. And believe it or not, a lot of banking solutions still use a lot of legacy technologies and still reside in on-prem data centers. So our solution had to seamlessly integrate with on-prem banking solutions while meeting all the requirements I highlighted. We also wanted to make sure that as new payment rails come on, we can easily extend the system without a complete overwrite, which was the old way of doing things. One example of this, we are seeing digital currency, stable coins, as becoming one form of new payment rail. And we will talk about how that is enabled by this architecture as well. And finally, because there are so many subsystems involved in a solution like this, it is critical for us to overcome the challenge of end-to-end observability. We only care if the payment we initiated from us was received by the end receiver. It might touch many subsystems in between. So end-to-end monitoring's job is to collect and make sure there is complete observability from the start to the end and up and down the stack. Now, I'll show you a very high-level functional architecture which highlights some of the main subsystems involved in such a payment processing solution. At the heart of this solution is this thing, what I call as the payment processing pipeline. Essentially, from financial institutions, the payments that come in go through a pipeline process. And here I'm showing only few key subsystems like payment validation. You saw that in the demo, payment orchestration, finally payment execution, and then the payments are sent over one of many payment rails. And we discussed earlier on the payment rails could be FedNow, real-time payments, wire payments, SWIFT payments, and now maybe even digital currency-based payments. And while the payment is being processed through the payment processing pipeline, we not only have to interact with banking systems that are located in on-prem data centers, we also have to do real-time fraud and risk management. Now, this is different than payments that used to settle in, let's say, 2 days, 3 days, or even after 24 hours, where you have time. Here, we literally, in real time, have to evaluate if the transaction has a potential fraud risk. Now, having seen this functional architecture, I will slowly build for you the AWS solution. How does this solution look like on AWS? So let's take a look at that. Here, we have the AWS cloud. Money Movement Hub solution has been built and is running in production on AWS. But outside of AWS, there are a couple of entities. First and foremost are the financial institutions who are the users of this solution. Now, as we said, the solution exposes APIs and the financial institutions interact via APIs. This interaction can happen over multiple channels. I'm showing here public internet with secure HTTPS-based API interactions. But some financial institutions are already on AWS. In that case, they will access Money Movement Hub over AWS's own secure private network. They don't need to go over the internet. Secondly, we have banking systems in on-prem data centers. So given the low latency, high performance requirement of our solution, we decided to use AWS Direct Connect. And for those who are familiar, AWS Direct Connect offers a very high throughput, very low latency connectivity between AWS and your data centers. And that's what we are leveraging for on-prem connectivity. Then what we did, at a very high level, we chose a multi-account strategy. What does multi-account strategy give you? Multi-account strategy essentially enables you to isolate different big subsystems of your overall solution into isolated accounts. AWS accounts offer a beautiful isolation boundary. It can be a compliance boundary, it can be a fault boundary, it can be a security boundary. But for us, there was one more important thing. We had different teams working on fraud and risk solutions, so we had a separate account for them. We had a separate team working on integration with different payment rails. We had a separate account. Then we had a core team working on the main payment processing pipelines. Each of these teams had a different operating model. For example, the payment rails team was a small team that did infrastructure and application all in one team. They could work that way. The payment processing team had a dedicated infrastructure team and a dedicated applications team. So a different operating model. Now, having multiple accounts allowed us to have these different models work seamlessly, and we interconnected all these services again using AWS Private Link, which goes over AWS Private Network. Now, let's take a look at the heart of the solution, which is the payment processing. First, let me touch upon the compute layer. As we highlighted, the compute layer is going to be critical in payment processing because it has to have high performance, high scalability. At the very highest level, the design decision we made was to use what we call event-driven design. Event-driven design with microservices, which are decoupled, and completely asynchronous processing. What this architecture allows us to do is to independently scale different microservices, which allows us immense horizontal scalability, and also creates resiliency because one service can fail, at the same time all other services can continue working. Now, we chose to use containerized compute to implement these services, and as we all know, EKS, or Elastic Kubernetes Service on AWS, is probably one of the most popular orchestration solution for containers. So that's what we are using to orchestrate the containers. Now here I'm showing you 3 of the key microservices, but there are dozens and dozens of microservices in the overall system. Here I'm showing you payment validation, orchestration, and execution services, just as an example. But all are built using Kubernetes, built using container, and orchestrated using Kubernetes. Now, not only did we use these native AWS services, we also used a few open source technologies, like CADA for the node scaling. We used Carpenter, CADA for pod scaling, Carpenter for node scaling, and we also used another open source tool called Conductor for workflow management. And soon we will dive a little bit deeper to explain you what these technologies are and what they offer. Now, any high performance payment solution not only needs high performance compute, it also needs a high performance transactional database. So for database, we chose Amazon Aurora with a Postgres engine. Now, Amazon Aurora is a cloud native database that is built from the ground up to support high scalability and high performance. It offers up to 15 read replicas that you can have within the same region. Okay? Its I/O throughput is extremely high, and you can get I/O latency as low as single-digit millisecond. So for all those reasons, Aurora Postgres was the perfect database, transactional database for our solution. But we weren't just satisfied with having a high-performance database. We also felt the need for a caching layer. Caching layer that provides not millisecond, but microsecond I/O latency. And for this, we chose Amazon Elasticache Redis to build our in-memory cache. And in-memory cache is used by the entire payment orchestration workflow, especially to keep real-time state, especially as we scale in real time to thousands of payments per second. And finally, not only are we processing payments in real time, we are also generating humongous amount of data. We need to store and process this data for compliance reasons, but we are in the age and era of AI. AI is fueled by data. And so for all the good reasons, we decided to build an S3-based data lake to store all the data generated by the system. I mentioned to you we are using an event-driven design, which means there are a lot of events being generated by the system and consumed by the system. To process these events, to move them from producers to consumer, we chose to use Amazon MSK, or Managed Streaming for Kafka. And for all the non-real-time processing, the data that is sitting in S3 buckets, we use AWS Glue. Again, these are very standard services, but for a high-performance system, these were the right choices for this solution. Now, observability I mentioned to you was an important element we had to address. Not only are we using all the capabilities of Amazon CloudWatch for observability, but we are going to highlight to you one unique capability that some of you may not be familiar with. It is a relatively newer capability called application signals. This allows you to monitor the application level, not just the infrastructure level, meaning service level objective monitoring. We'll talk a little bit more about that as well. And finally, to round out, we all know the system like this needs to be extremely secure, so we use Amazon security services, AWS security services like KMS, Secrets Manager, and HSMs. Now that you have a picture of the overarching solution, I would like to invite my colleague Ilango to really dive deep into how we address scalability, performance, resiliency, and observability. Ilango?
Thank you, Samir. The solution that we had to build has to provide scalability, performance, resiliency, and end-to-end observability. Let's dive into all these aspects in the subsequent slides. Money Movement Hub is written in Java 21, and the front end is written in Angular. The entire solution is deployed in EKS. To provide the massive scalability that we require, we use SCADA, the pod autoscaler. SCADA looks into two metrics, HTTP request count metrics and the elastic cache queue depth metrics. HTTP request count metric is a direct correlation to the number of payment APIs that we get in. Each payment API, as we saw, is a complex orchestration. For that, we use open source Conductor. Conductor is an orchestration engine. It converts all those orchestrations into workflow. Each workflow is divided into multiple smaller units of work called tasks. These tasks are put into a Redis queue, and the queue depth is number of tasks that we have to do to complete a payment. So CADA looks into these two metrics, and based on that, it scales the pods. We want the pods to be immediately schedulable and start running. For that, we use warm pools, and in the warm pools, we run low priority pods, and all our money movement hub pods have high priority. So Kubernetes, using the priority class, preempts the low priority pod from the warm nodes, and then schedules our high priority MMH pods in the warm nodes. So our pods are immediately schedulable and start running. This solution works for most of the cases. In case where we need additional worker nodes, we use Carpenter, which quickly brings in the additional worker nodes and attaches to the EKS cluster. The next problem that we have to solve is providing enough IPs for our pods. For that, we use custom VPC CNI plugin. We use a secondary non-routable IP ranges for our pods, and the worker nodes run in a routable IP space. We use /20 CIDR blocks for our non-routable pods that gives us enough IPs for our pods to scale. With respect to application, we built our application using open-close principle, open for extension, closed for change. Our business demands a lot of changes with the application. As you all saw, workflow payment is a complex orchestration of changes that we have to do. One such workflow is here. You see how we are using parallel tasks and how we have multiple deciders, which changes that workflow based on multiple parameters. And Conductor helps us a lot here. Conductor also manages multiple versions, so we can use any version of workflow. And if there is a problem, we can roll back to an older version too. Our operation teams love Conductor UI. They can go to Conductor UI, monitor what's happening with respect to all the workflows. They can rerun any workflow. So they kind of love it from the operations perspective. When it comes to performance, we look into performance in two aspects. One is pod startup time and data access. For pod startup, we use BottleRocket, a purpose-built container OS. We also try to keep our application Docker image small. We use multi-stage Docker build to add only the libraries that were needed for the runtime. We also carefully evaluate all the Java libraries and add only that's really necessary. This helps us to keep our Docker image small. We also use Spring's lazy bean loading to load only the necessary beans that are needed for the startup. These techniques helps us to start our pod in under 4 seconds. For data access, we created custom Spring annotations to send all the read SQLs to the Aurora read replica. We use 2 to 3 read replicas, which provides enough performance for our read SQLs. Anytime when we need a fast write, we use write-through cache, wherein we write everything to the elastic cache, and then we asyncly update our Aurora endpoint. We're also evaluating a couple of things. We're looking at Spring ahead of time to compile the image at the build time. Also, we're looking at Gravel VM to create a native images. One of the key features of BottleRocket is a seekable OCI, which does parallel Docker image pull on demand. So we are also evaluating that, which all gives us the fast pod startup. For multi-resiliency, as Samir mentioned, any service that we take, we look for whether it provides a native cross-region replication. Amazon Aurora provides global database, Elastic Cache provides global data store, and S3 provides a native S3 replication. For Kafka, we use MSK replicator. MSK replicator not only replicates the images, but also replicates the consumer offset. So if the application is running on other region, it can consume from where it stopped. We use Route 53's failure routing to route the traffic based on the region failures. We constantly evaluate this setup using AWS fault injection service. Fault injection service provides multiple documents where we can simulate the failures. For in places where we need custom script, we use Lambda. As we have multiple microservices which are running in multiple accounts, we want to provide a unified observability. For that, we use OpenTelemetry. AWS distro for OpenTelemetry is the library that we chose. Auto instruments for Java and Python. It captures all the observability signals, be it logs, metrics, and traces, and sends it to CloudWatch application signals. CloudWatch application signals is a new application monitoring service in CloudWatch. It provides app dashboard, telemetry, tracing, root cause analysis, and end-to-end visibility. From our account, we send it to the centralized observability account. We also use Firehouse and AWS Lambda to send logs and metrics. For the traces, we use trace propagation, where we use the same span ID for the multiple APIs, so we get a tracer bullet view of how the API is flowing through. I want to highlight one important feature of application signals. That's called service level objective. Service level objective tracks the objective based on multiple service level indicators. You can see in this example, we are tracking objective, which is a receive API latency, which is to provide a latency under 1 second, and we have to do it for 99.9% of time. So that's our goal, and the indicator that here we are using is HTTP latency. So this dashboard quickly gives us a glimpse of what is our goal, what's happening with respect to that objective, and when we last met the objective. Our leadership team loves this because any point of time when they ask, hey, what's happening with your app, we just tell them this metric, and they kind of quickly understand the performance that we're giving to the customers. The banks also like it because it helps them from the compliance perspective. The SLO can be obtained not only from EKS workload, but also from ECS and EC2 workload too. These are some of the techniques that we use to meet the business needs. Now we'll pass on to Aid.
Thank you, Ilango. So we're going to talk about outcomes a little bit, and really just quite incredible the time that we saved ourselves in having the technology behind the ability of building this product in a rapid time. From concept to production was 9 months, but actual build, we started in August 2024, and we were in production in January 25 in pilot with our first 2 clients. This was pretty remarkable for FIS. Traditionally, our payment systems, you would go and install, you would take time to actually deploy, you would actually onboard, and that could turn into many, many months. So it was a key requirement when we first started development that we would build something that would be easy to implement and easy to deploy. And we turned the deployment of what we would call regular implementation into an onboarding activity. So that means that you build it into the product. By doing that, however, you cause other issues within your organization. FIS has a pretty strict change management implementation profile. It also has a lot of manual testing and a very, even though we run sprints and we run very, very quick development internally, traditionally we've not done things in the way that we had automation around these systems. Observability brings a new problem that we needed to look at how our teams were orchestrated, actually built for support purposes. They needed to understand the new technologies from an orchestration perspective. We hired full stack people into our support organization so they understood the infrastructure as code, the automation that we were using, and the deployment methods that we had. We moved to a CI/CD model using Harness as the CD to allow us to actually deploy quickly. And we're now in a state that we can deploy 3 or 4 releases into production every single week. This was a complete change for FIS. We had to go change our change management solutions. We had to bring different people in from the perspective of understanding how to actually operate in that environment. And we had to introduce new automation of testing. So with Harness and Zephyr and Cucumber, we created test automation for the ability to actually run those tests on a regular basis so that as we implement new parts of into production, we continue with that automated testing to get us to that endpoint. That was all new for us. And we carry on. So the outcome was effectively into production in January. We embedded the system. We went through hardening of the system. We went through our complete testing for performance perspective. We looked at our timings in terms of our performance throughout the chain, meeting our SLAs. We also adapted some of our core technologies to help us get to those cores in a more rapid way. So once we built this solution, it got little tips everywhere into the FIS ecosystem. And that allowed us to improve that ecosystem and then share that with other parts of FIS. So this became a really strategic play for us. And when you look at where we are now, with 30 clients in production, we've signed 100 clients, we're going to start mass migrations next year. We've now been adding different capabilities onto it. So we started with the instant payments. We started with FedNow and TCH. We wanted to prove that we could build something at scale that would handle instant payments. And then we're adding additional rails. So what's next in the solution? So new payment rails is a given. I said at the beginning of this that payment rails are table stakes now. Adding ACH and wire are the things that everybody does. The more important part is how we embed them now in the orchestration process. How do we get intelligence in our environment? How do we make smarter decisions on decisioning for routing those payments? And so, as we speak, we're adding digital currencies, we're adding stablecoin. We had a partnership with Circle. That partnership is growing, and we'll be live in production very soon in Q1 in the hub. And it's a good example of adding another scheme very quickly into the ecosystem. Once we got our orchestration and execution correct, now rail additions are pretty straightforward. We're also building, as I mentioned, SDKs for initiation. We're building ways of improving the experience so that customers and our clients and their corporates can make quicker decisions and have that automated. The AI components of this become really crucial. There's 2 ways we're using AI. One is the improvement of payment exceptions. How do you repair payments that actually have gone into a state where maybe a core was unavailable or the account was unable to post? We don't want to leave any payment behind on whatever rail that happens. So this was critical in the way that we actually built the testing automation to get us to the point of being able to quickly add on that rails. And then AI used for smart routing and intelligent routing. Now I start getting really interesting about actually satisfying what I said at the beginning about customer expectations. If I want to move money today, I don't have to tell you what rail it needs to be. Let the system go figure it out based on my history, based on how it's processed, and based on the configuration of my consumer base. All that comes from data. So the data lake that's been built is a massive amount of data that's helping us and feeding us into the loop of payment execution. And as we go through that payment execution, we go through the fraud data, we go through the fraud execution, we determine what that fraud looks like, that becomes a wider across our rails, that becomes more important data, which feeds into the loop of the data exchange, which allows the AI to start making more decisions based on where those payment routes should be. The next piece of this is also international. So AI is going to help us across border. So we're adding push to card, push to account on both the 2 major networks. And then we're adding universal rails for the purposes of moving money in a more efficient way. whether that's through digital currencies for off-ramping and on-ramping, or whether it's a particular own rail on an on-us payment method. So these are all critical items that are feeding into the next piece of this generation, and the technology that's been built is allowing us now to rapidly add. We have 11 initiatives for next year. The initiatives cover refinement of the AI models for the data lake so that they started making decisions. The build out of the payment exception processing and the payment repair processing so that they're using the AI to make our operations more efficient. Self-service to our financial institutions. We're actually enabling our financial institutions to come in and make the decisions they need to make rather than we making the decisions, rather than them having to go through manual operations. Remember at the beginning, I talked about that expectation around automation. So we're now starting to put the automation in place, which is now possible because of the way that we built the platform in the first place. So these were all great outcomes that effectively allowed us to get to a point of being able to mass deploy into production every single week, and now start our migrations from our legacy platforms and start to decommission those platforms over time. I'm going to hand over to Samir to do the lessons learned. I think, from my perspective, this has been a great collaboration that we had, and that technology has allowed us to move as quickly as we can. So, Samir.
So we, in this session, tried to quickly walk you through our journey from the time FIS conceived of this solution to us gathering the requirements, architecting the solution, building the solution, and now we have the solution in production on AWS in a very short order, plus it is scaling up with a lot of customers. So whenever we go through a journey like this, we learn a lot of lessons. Not everything works right the first time. So what I want to do is share 4 key lessons from this journey. Hopefully, these will be valuable to you. First and foremost, whenever you are thinking of designing and building systems that require massive scale, start by thinking about event-driven architectures, event-driven designs. What this allows you to do is decouple various subsystems, implement them as microservices, and do completely asynchronous processing. These technologies give you massive horizontal scalability, which means you can add more compute and your system automatically scales. We did this, as you saw in our solution, by using Kubernetes to orchestrate our containers. Second thing I wanted to highlight was on high performance. To build high performance systems, especially those that have real-time requirements, it's very important for you to identify what is your real-time processing pipeline. Not everything in the system needs to be real-time. But the pieces that need to be, we need to optimize every single step of that pipeline. Now, in our solution, as you saw, we focused not only on optimizing the compute layer, not only on choosing the high-performance database layer, we added high-performance caching layer. We also optimized boot-up times. We optimized the size of Docker images as well. Okay? We started keeping warm pools of nodes so that when the system experienced load, we could instantaneously scale rather than booting some cold nodes up from scratch. These are all techniques that allow you to build high-performance systems. Now, resiliency is exceptionally important for a solution like this. In AWS, most services actually inherently offer you multi-availability, multi-AZ high availability, which means most services operate across multiple AZs within AWS. That's a core architectural design principle we have. For a solution like this, where we could not tolerate more than 30 minutes of downtime in an entire year, we also chose to build multi-region resiliency, which means this solution simultaneously runs in at least 2 different AWS regions. For example, US East 1 and US West 1. Now, sometimes people think that building region resiliency is going to be either expensive or difficult. In this case, what we showed to you was by prudently choosing some AWS services, you can actually get a long way there because some of these services natively have capacity to do multi-region support. For example, Aurora Global Database has ability to replicate across regions. So does Redis, Elastic Cache Redis. So does managed streaming for Kafka. And of course, S3 has cross-region replication as well. And finally, to build unified observability end-to-end, it's important to think left to right, end-to-end, as well as top to bottom. Left to right meaning you cannot leave your on-prem systems like they are separate silos. For observability, we need to aggregate all the signals, logs, metrics, traces, bring them all together. That really is a powerful unlock for a solution like this. You get deep visibility into if things go wrong, where did they go wrong, and how to then fix them. Secondly, many times we focus on infrastructure or technical metrics, but in this solution we highlighted to you by using something called application signals. We are not only monitoring the technical aspects of the solution, the infrastructure and the application, we are also monitoring service level objectives, which are more akin to business KPIs. So hopefully, all these 4 lessons will be useful to you as you build your own solutions on AWS. And with that, I truly want to thank you for sharing your time with us. And if you'd like to continue your learning journey, I have some QR codes here that you can scan. But please do take a moment to share the feedback in the mobile app. It helps us a lot to improve the sessions in the future. Thank you very much.